Okay, so question number 5 deals with differentiation. You're given a curves equation, and the first part says find dy by dx. So what is differentiation? It's just when you have x to the power n, it differentiates to become nx n minus 1. And if x has a coefficient, you're just going to multiply the power by the coefficient. So your first step should always be to rewrite the equation into something you can differentiate. So y is equal to 4x cubed plus 2, and you want to get rid of the fraction. So you bring that x up, and it's going to become minus 1 plus 9. Now you have to find your dy by dx. So 4 times 3, that's 12. X, 3 minus 1, that's 2. 2 times minus 1 is minus 2. X, minus 1, that's 2. And 9 is a constant, so it will disappear. Don't even bother, because if it was to have a power, an x, it would be x to the power 0, because x to the power 0 is equal to 1. And 9 times 0 is, well, 0, so it just disappears. Now, if you were to rewrite this, it would be equal to 12x squared minus 2 over x squared. Either work, they're both the same thing, and you're going to get marks for both either ways. Now for the second part, it says, given that the point P lies on C, the line with equation k minus 5x is a tangent to C at P. Show that the x-coordinate of P satisfies the equation. So what does this mean? If the curve C looked something like this, it's not exact at all, it's just to show. If this was the point P, the tangent will be over here. The equation of this tangent is k minus 5x. What does this mean? So I'm going to rewrite this. So the equation of the tangent is y is equal to k minus 5x. If you were to write this in the form y is equal to mx plus c, because it is a straight line, it would be y is equal to minus 5x plus k. So this means the gradient of that tangent is minus 5. So, well, really it would be going down. That little diagram I drew was wrong, but it's fun. So what does this mean? At the point P, if you took point P has coordinates x and y, correct? If you were to take this x and substitute it over here, you solve it, you would get minus 5, because dy by dx is also your gradient function. So they're asking us to show that the x-coordinate of P satisfies this equation. What do you do with the facts that you do have? We know that 12x squared minus 2 over x squared is equal to minus 5. And we want to simplify this as much as possible. So first of all, let's try to get rid of the fraction. How do we get rid of that? Multiply everything by x squared. So 12x squared times x squared, that's going to become 12x to the power 4, because x squared times x squared, that's just x 2 plus 2. Minus 2 over x squared times x squared, it's going to cancel out. Minus 2 is equal to minus 5x squared. Just rearrange that. So 12x to the power 4 plus 5x squared minus 2 is equal to 0. And there we go, that's part B solved. In the third part, we have to find the value of k. So how do we go about doing this? First of all, we have this 12x to the power 4 plus 5x squared minus 2 is equal to 0. We have to solve this to find that x that we want. So the easiest way to solve this is to substitute, because usually quadratic equations are in the form ax squared plus bx plus c. So take any letter. I'm going to take k. I'm going to say let k is equal to x squared, and that would also mean that k squared would be equal to x to the power 4. So let's rewrite that as 12 k squared plus 5k minus 2 is equal to 0. And you just use your calculator to solve that quadratic equation. 12, 5 minus 2. So you get k is equal to 1 by 4, and k is also equal to minus 2 by 3. So we're solving for our x, so we're going to write that as x squared is equal to 1 by 4. Just root it, x will be equal to square 1 by 4 square root, so x is equal to 1 by 2. And in this one, x squared is equal to minus 2 by 3. Automatically, you should know that all numbers squared, even if it's negative, gives us a positive number. So there's no way anything squared will give us a negative number. So this one will have no solution. And you should just write that. So our x, we have found it to be 1 by 2. And then we have to find our y as well. So we're going to use the original equation we have, this one, to find our y. So y will be equal to 4, 1 by 2 cubed, plus 2 over 1 by 2 plus 9. Just plug that into your calculator. And you're going to get 27 by 2. Okay, perfect. So we have our y and we have our x. So 1 by 2 and 27 by 2. So we are solving for our k, and you are using both equations because, look, the tangent and the curve, they share this point in common. P is common in both, so you can use both. So the line with equation, this is our gradients, and we're solving for k. So if y is equal to k minus 5x, that means that y plus 5x should give us k. And we have a y and we do have an x. So k is going to be equal to 27 by 2 plus 5, 1 by 2. Perfect. Just put that into your calculator and you should get k is equal to 16. K is equal to 16. Perfect. And that is question 5 solved.